Okay, welcome to the sixth practical of ESP today. Today we'll just continue talking about pointers, arrays, and strings. Maybe just go over the stuff again we did last time. So a recap. Then we'll look at the reverse string function a bit more. Now that was last time introduced in the lecture, pointer arithmetic. I think this was just a quick overview, but we'll talk a bit more about it today. And then also about 2D arrays and user input, which you might need at the assignment.
There's a slight hint. The last 2 bullet points of our list are related to assignment 2. That's why we've chosen them. So it can be helpful to watch these parts. Should I do that? Yeah. Mm-hmm. So organizational matters, as always, in the very beginning. Regarding weekly exercises, so the last 2 times there were each 3 exercises on online GDB. All of these are related to assignment 2. And today we will release 5 exercises for assignment 3, and it will be the only 5 exercises for assignment 3. So you need to do 3 out of those 5 to avoid deductions. Now a bit our problem child, if this translates to English. So the coding session 2. This week there were many slots, but only few students. So there were many empty slots this week. Next week we have the same situation. So if you have not registered yet for a coding session 2 slot, it is now a good point to register to one of them.
Because all of those slots which are near the end are already full.
And if you do not have a slot next week, you most likely will not have a slot for the coding session 2. Yeah. So please register if you haven't done this yet. And something new. Assignment 2 releases today. As also it was for assignment 1 at 6:15. And today's evening after the lecture there will be the kickoff video on YouTube where Lena will introduce you to assignment 2. The repositories will be available, I don't know, I haven't checked this yet, but probably today's evening.
But you'll definitely get the upstream repository once the kickoff video goes live.
And you will receive a notification once your repository is ready. And the deadline is in 2 weeks, yesterday in 2 weeks at midnight, as always. Okay, recap. Yeah, so last time in the practicals we saw mainly pointers, arrays, and strings. And we probably need to admit that it was slightly too advanced maybe for the first lecture about arrays, strings, and pointers. So we try to be a bit more basic today and explain everything we did last time one more time to make it a bit clearer, hopefully. So we recap with a very simple thing, which can be awful if it becomes too complex, but what is a pointer? So basically it was just we store a memory address of some other variable. And if I look on the C code here, we have our integer a, which has some value, doesn't matter which value it has. And then if we go to the address of a, then we have the address of a and can store it into a pointer variable. So this is the integer pointer to a. Yeah, so this should be, I think, clear. Now, today you will see, 20 pictures of us drawing this in the memory, because we think that it is very important that you can think about this visually in this way. So our first picture for today is this. Yeah, so we have the main function indicated in red. Then we have, like in between these lines, in these drawers, we always have our variables. On the right side, there will be the name of the variable. In the middle part, the value. So what is stored in the memory there. So this is basically the name of the memory. And when we have this integer a, then we draw it like this. So we just have here the value 5 in the memory. And then we have this pointer variable, this pointer to a. This is also a variable, so again indicated with this box here. And the value of this variable is the address of a. And we think about addresses via these arrows, via these pointers. That's what's called pointer.
Because this pointer is pointing to a.
So, and this is the most basic thing that we can have here. And as always, if we dereference a pointer, so we have this address of a, if we dereference it, then we go along the arrow to the next variable. And in this case, it is the a, which has the value 5. Yeah. Okay.
Yes. What exactly we then do there depends on how we're using this expression. But when we dereference this pointer, we always go to the original memory location and then either write something there or just read from it.
Yeah, so we can
so
also...
this then depends.
Yeah, we can demonstrate this. So if we would do something like integer b equals dereferencing pointer to a, then this would imply that we read from this memory. And if we do something like this, then we write to this memory. So it basically just depends on which side of the assignment operator the pointer is. Okay. I hope this is clear. Then next step, what is an array? So, I mean the basic concept most of you already used in assignment 1. So we want to store multiple elements of a same type. Yeah, so this integer, my array, has 5 values. It has the length 5, so we can store these 5 values. Yeah, so clear so far. Now, second image for today. This is the visualization in the memory. So we have this array variable here, and then we have 5 elements, 5 consecutive elements in the memory. We always start from the bottom because we increase in the addresses. And the 0th element is the one with 1, with the value 1. Go back here, the first or the 0th has the value 1. Then 2, 3, 4, 5. And we also draw this here in the memory. So we have these 5 elements consecutive in the memory. Yeah, I think this is so clear so far. Now we want to combine these two concepts.
So this might now seem weird, but many of you already implicitly used this at assignment 1, because here we just saw, okay, this my array lies somewhere in memory, but now we are directly assigning this to a pointer without using the address of operator. So what happens here?
Yeah, so look on the picture again. What do we have here? We have the array again, and then a pointer to the array. This is again indicated in blue with this address of, and this points to my array. Well, this seems kind of logical, but now we have this pointer who points to this 0th element of the array, and we have this my array variable which does not point to the memory. But what is the difference between those two? If we have the pointer, we can also access the elements. If we have the my array, we can access the elements of the array. What is actually the difference here? So actually, if we think about it a bit more, then my array and pointer to array are both pointers to the array that is in the memory. With a slight difference here, because the my array pointer, so the name of the array, it implicitly has this arrow information. It implicitly has this pointer information here. So it is a pointer to the 0th element of the array, but it actually does not have any memory. So this variable myArray is not stored in our C program. It's just when you code it, you use it as a pointer, but actually it's not stored anywhere in our program. That's why we have this variable name kind of outside of this visualization, and we only have the pointer to the 0th element. And the pointer to array is really a variable that lives in our code that has some memory, and in this memory the address of my array is stored. It seems a bit weird in the beginning, but actually you basically need to think about it like this.
Yes. And it also, if you work with it a bit more, it also makes sense, because then this allows you to handle pointers and arrays very similarly, which makes much sense and makes things easier.
We will see this also. Yeah, we have a question.
So the question was if just the address of the 0th element is stored in pointer to array, or if somehow a pointer to the whole array is stored. And yes, so in pointer to array, just the address of the first element is stored. And then we basically know that after this one, and we know that there is the next element if we just increment the address, but we'll come to this later.
Yeah, but basically we just have the address to the 0th element. So the address of the 0th element is also the address of the array. This is the same thing here. Yeah. And also this myArray variable is just the address of the 0th element. And we know if we go 4 addresses further, then we always get an element of the array.
Mm-hmm. So if we index myArray at position 0, so with these square brackets, and then take the address of that, we get the same address as myArray basically holds or pointer to array. So the question was if we can get to the first element just with pointers. And yeah, that's a really good question, and we will see that later.
5 slides.
Yeah.
Then we are there. But this is a very good question, yeah. Yeah, so we are already at indexing an array. But it's not even 5 slides until we go to this question.
It was the next slide.
Basically, yeah. So we have again our array consisting of 5 values. And this is something that you have already used in your assignment. So you used my array of 3. Most of you used it. All of those who used an array in the assignment. So we go to the element with index 3, and this should be 1, 2, 3, 4. What is my array plus 3? This is now a good question, and let's look on the visualization. We start with my array and then with the brackets and 3. We said this is just the element in this array, so this is the 4. So this is not an address.
So this is the actual value now.
So really the integer 4 is my array, and if we dereference at 3. If you write my array plus 3, then you take my array, and remember this is just a pointer to the 0th element. And when you increase it by 1, then you have a pointer to the element with index 1. If you increase it by 2, you have a pointer to the element of index 2. And if you increase it by 3, you have a pointer, as indicated here, to the element of index 3. This is a pointer. So if you write my array plus 3 and print it, you will not receive the value 4, but you will receive the address of this memory location. So the address of the element with index 3 in the array. Should we try this in the code, or is this clear? Should we maybe code this and print this? Does somebody not trust us? And we come to the printing a bit later, maybe.
Okay, so let's just a quick recap how parameters are passed to functions, because this will get a bit more complex now. So if you remember, if we have just any function and have this integer there, and then we can just pass an integer from the main function into this function. And I have this drawing here. So as we have seen, here's the function, this is the name of the parameter, and this is the integer from the main, which we pass to the function. And as you can see, these are now two separate memory locations. So these are two different variables, and the value was just copied at the function call. So here, if we change this 5 to a 4, nothing will happen in the main. Yeah, we already said this a few times, but this now will get a bit more complex. So
I just want to add something here. Yeah, we can spoil this on the second last day of the assignment interviews. But at least I ask this very often. What happens if the x changes? Does my int change? And many of you did not answer correctly. So this is really crucial, that this is a copy and the parameter x in the function is something different from the actual my integer, which lives in the main function. These are separate. If these have separate memory locations, and if you change one of them, the other does not change. Yeah, now please continue.
Yes. So, but what happens now if we use a pointer? So here, this function will now take an integer pointer, and I'll here with the address of operator pass the address of my int in the main to this function. And now it will look like this. So we have this pointer to the integer, which points to the memory location of the 5, which is the my int in the main. And now we actually can change the value of the integer that we have in the main. In the last example, this was not possible because these were two different variables. And now there are still two different variables, but the second one is the address of the first one. So we can follow this pointer, which is stored in this variable, and get to the my int in the main, and now read this 5, or even set this 5 to a 4, and then actually change the integer that we have in the main.
Does somebody have a question? This is like really a core concept. Everyone it's clear. Okay. Yeah, then make it more difficult, please.
Yeah. Okay, so what happens now, as we said, arrays behave as if they were pointers. What happens now if I have this array in the main, and now I take this integer pointer in this function, and pass this my array to this function? Well, as we've seen before, where we didn't have a function call, but just a pointer variable, we now just have the address of my array in the main in my function. And now with this array, I can just index it at position 1 or at position 2, which will change the pointer to the correct element, and I can read and set the data that is there. And yeah, a few of you actually used that this works in your A1 assignment, because you passed an array to a function, then changed the contents of this array in this function, but this somehow also changed the contents of the array in the main. And this works because it was actually not a new array in this function, but you always just passed a pointer to this array.
Should we do a short program example on that, maybe? I was lazy. I just need to copy the code from somewhere. Make it a bit larger for you, maybe, that you can see something. Don't need this. in cheat mode. Should I set to off? So. Maybe what is your favorite element that we should print? What
Maybe
index?
let's look at the second one.
The index 2 or the really second one?
Yeah, at the second one.
So the actually second one, okay. So we have my array at 1, and yeah, if we just leave it like this with the function being empty, then hopefully nothing should change. If we run this, let's make a \n. Then we just have array at this index, and we print the 2. And now, really, if we go into this function, and we say, okay, our array at the index 1 should be 100. And if we run this now, then the element is 100. And note, this is the pointer to the array. So this points to the memory location of this array, and we change something in this memory location.
Yeah. And so the actual content of the myArray in the main function changed. Maybe can you use the other syntax for passing the array to the function up here?
Ah, you want this syntax,
yes.
Yeah?
So I just want to show that you, of course, also use this, which I saw very often at assignment 1, but this is just basically the same. So you're also passing a pointer to the first element of the array to this function, which you can then change.
So let's try it. It's again the same thing. Okay, if I hover over it, it's different here, but basically it really means the same. Now we can modify this a bit. I take the function and I pass to the function only the element at index 1. Okay, so this is now really the element of index 1, not the array anymore. In this case, I will get an integer here, and yeah, let's leave it array, doesn't matter, and set array to 100. What is the output of the code now? Yeah? 2? Yeah, let's try it. Yeah.
Yes.
Correct. Why is that the case? Because in this line, we pass my array indexed at 1. And we said if we index, then we directly get the value, not some address. We get the value of it. And if we pass on the value, we get now an integer in the function. And this is a copy, as we said before. We change the copy to 100, so the previous value is unchanged.
Yes, and now, because we think of myArray as a pointer, these square brackets we have here basically dereference our array for us and just get the value, which is stored at this index.
I have a hard example now.
Mm-hmm.
So maybe we go back. Yeah, we go back. We have again the array. We can even write this as a pointer, doesn't matter. We have the array. We print my array at 1, and I pass now my array plus 1. Why can I do this? If we go back to the slides and somewhere up, then we said, okay, my array plus some value is a pointer, and this is a pointer, we can do this. Then we say, okay, array at 1 equals 100. So first question, what is the output of this program? Mm-hmm. 100. Other guesses? 2? Who would say it's 2? So raise your hand for 2. Who would say it is 100? Equally.
About 50-50.
Yeah, I don't know. Let's try it. It's 2. 2 was the correct answer. Now we need some explanation why this is the case.
Yes, so basically what we did here, we have seen that these square brackets just add to our pointer and dereference it at that index. So if we here pass array plus 1, and actually we are passing the pointer to the second element, so to the 2, to this function. And in this function, we now access the first, so not the first, this second element again, but we think that our array starts at this 2. So we are actually accessing the 3 and changing the 3 to 100.
Maybe I can open the visualization next to it. Yeah, maybe this works. So my array plus 1 would be a blue arrow. I hope the mouse is large enough. Yeah. It's a blue arrow pointing here to the index 1. And we pass this blue arrow to the function. So starting from this blue arrow, we go 1 to the next element. So this is the blue arrow. So we go upwards and access this element. So we access the element with the index 2 and a value 3. Yeah, so
but we'll talk more about this also later again.
Yeah. But I want to print this now. So if we now really access the element, so in the printing, we directly say my array and go 2 steps upwards to the 3. And in the function call, we said we go 1 step upwards, have this pointer, and then go 1 more step upwards to the 2, to the index 2. So this element should be changed and set to 100. And now if you run the code here, then here the output should be 100. And if we do this, the output is 100. Yeah, we will talk about it in a minute, no, in 15 minutes, a bit more. But you should have seen this already. Okay. That was the last slide.
Yes.
Yeah. Now something more easy. This is the easiest slide probably. What is a string? A string is just, is it an array? It uses an array. It is an array. It lives in an array. Let's put it like this. And it has always the last element of a string is this null byte. So this is written as a character, or it's just a byte with the value 0, a character with the value 0, if you print it as an integer. And for example, if we have this my string here in our main function, then you see hello has 5 letters, and we need this additional null byte at the very end. That's why the array has size 6. And if we look at it on the memory, this is again an array where the characters are stored, and at the very end we have this null byte. Yeah, so this is the similar thing as an array, but with the null byte at the very end. And it is also possible, of course, that the string is, the array where the string is contained is larger. So we could also write, 100 here. Then we have memory for 100 characters. We have the hello, the 5 letters are in the first 5 elements of the string. Then we have this additional null byte. And the remaining 94 characters in the array are some rubbish that is not initialized at this moment. But this is no problem. We can have larger arrays and smaller strings. The other way around is not a good idea. To have if you just have this, then you have only memory for 5 characters, but this string needs 6 characters, so don't do that. Yeah, this might lead to severe problems where you search for a long time and maybe don't even fix it at the very end. Yeah, so let's put the 6 here again. Any questions regarding the recap, pointers, arrays, strings? Okay, yeah, then Last time the example was the reverse string function. So what did we have there? We read a string from the user. Then we have stored it somewhere in the memory. Then we reversed it, and then we printed it again. And most likely this was really advanced for you last time because you haven't seen that much about arrays and pointers. And yeah, we want to go through the code one more time. And
we also have some illustrations.
More drawings, yeah. So the code, maybe switch here. Okay, so we had this main function here where we had a buffer, and I drastically decreased the size of the buffer that we can draw it. Then we used the fgetS function to read in a string from the user and immediately removed the new line. But we didn't talk about this. Then we printed the string, we reversed the string, and we printed the string again. Yeah, so the interesting thing is the reverse string function. Okay, let's talk about it one more time. We have an array here. We pass the array to the reverse string function. This is an array, and as we said before, we get a pointer to the array here in the function. Then we have this length calculated of the string, and then we did some loop over the string, and then we swapped the elements of the string. So the first and the last, the second and the second last, and so on and so forth, with our usual swap function. So let's visualize it. Maybe it works that is this large enough? Large enough is okay. Yeah, okay, yeah, nobody complains. So what do we have in the main function? So I should make it larger, that it matches the picture. So we have our buffer of size 7. I increased it by 1 now. So we have printed this here. So we have the elements from index 0 to index 6. And we read in with fgetS hello \n. So we store hello \n in the string, but then we remove the new line and basically wrote a null byte here that we just have hello and the string is terminated. So this is the content of the memory if we print the buffer at this printf here. So now we call the reverse string function. So more visualizations. I make it now larger. Is it larger? It is not larger. Okay, so this is the visualization here. So we have the main function where we still have my string here contained. And then we have the reverse string function. And we have here this my string. I should write my string here. I'm sorry, this doesn't match the picture. It's again called buffer. Now maybe fix it very fast. My string, my string, my string, and my string. Okay. So we have this my string address, and this points to the string from before. And then we have some additional variables. So we have the length. This is stored here. So the length is 5 because HELLO are 5 characters. And then we have this integer I if we are in the for loop. And it has at the very beginning of the for loop, it has the value 0. So we have in this reverse string function, we have 3 local variables, which are the my string pointer, the length integer, and the I integer. And these are stored here in this function. Okay, and for now, assume that the I is really 0, and now we go to the swap function. So make the visualization a bit larger. On the left part, everything is the same. So we still have the main function with the array. We have the reverse string function with the address with the 5 and the 0. Now we call the swap function. The first parameter is my string at position I, and we said here that the I is 0. So it's my string at position 0. And
the address of that.
The address of that. So we get in A, I don't know, I think I looked at another code here. So we have the, let's put it here, A, and A. So we have here at A, this is a character pointer, and this A points to the element my string at position 0, because we said this here. We have my string at position 0, the address of it, so we have a pointer to the string here. And then here for the other parameter, my string at length -1 minus I, so length is 5, I is 0, and yeah, so we have 5 minus 1 is 4 minus 0 is 4. So we have my string indexed at 4. This is the O. Again, we take the address of it. So we have now address of the element 4 here. So we go upwards here.
Yes, so we need the -1 just because our indexes start at 0, but when we're counting the string length, we start by counting with 1. So we need this -1 to get from our position to the index.
And now we have these two pointers here in the swap function. These point to the corresponding memory addresses. And now that's what we have seen, and I think also we have seen this in the lecture at some point. We can do this swapping procedure where we store in the temporary variable the value of one of these, then write the O here in the H, and then write the H back to the O and do the swapping procedure. And after we left the swap function again, everything on the right side is gone, but the two elements in the memory of the main function are swapped. That's why we use the pointers. And we would not be able to do this if we would not use pointers. Are there any questions regarding the reverse string function? Yeah. Yeah, that's a good question. So the question is, why is here the main function, and then below there's the reverse string function, below is the swap function. There must be some way how the memory is structured, and think about the memory like a block, and something starts at the bottom to grow, and something starts at the top to grow. Yeah, so that's what is on the top grows to the bottom, and from the bottom to the top. And it's now basically a convention that you do it like this. So the local variables or functions, you start at the top and grow it to the bottom. So you have at the very, very top everything which is related to the main function, and then below everything is related to the next function that is called, and in our case the main function calls reverse string, so this is below. And then again below there is what is called in the reverse string function, so the swap function in our case. So this grows from the top to the bottom. Yeah?
It actually doesn't matter, does it? Because the whole program gets compiled afterwards anyway. It's not like in Python where it gets interpreted.
So the question is, does it matter how it is structured? And this is basically the way how it is structured from the compiler. So this is the way how the compiler it takes the program and structures this, that a computer can read it. Of course, it doesn't matter how it is done, but it always needs to be the same for all programs. Because basically at the very end, your operating system, like Windows or Linux, gets now the program, and now it has to work with the program, and it needs to understand it. And that's why we have this convention that this part of the memory is always structured from top to bottom. It's the same for every program.
Yes, and this now is also very low level because this also depends on the hardware and the computer you have, and we just now in our illustration drew it like that, so it most resembles how it is structured in modern computers. But of course, just for illustration purposes, you could order it in any way you want and can think about it in any way you want, and it would probably still work.
Yeah. Latest at operating systems or system level programming, you will deal with that and you will implement this also on your own parts of it. So behind this visualization, of course, many things are hidden. Yeah, so this where we have here main written, this is also some memory that is used for internal information, which we do not care about as programmers at this point of the course or at this point of your studies. But you will care about this later in operating systems, for example. Further questions? You move on.
Mm-hmm. Okay, so now let's talk about something which we have first seen last lecture, I think very briefly, about pointer arithmetic, and what we've also used today, so that you can add stuff to pointers in order to manipulate the address that is stored, and we've used that to index arrays. So let's look at this a bit more closely. My first question is, what does this do? So we have this array here, this char array, with 5 elements. And now I have this pointer, and this pointer points to array plus 2. And now the question is, if I dereference the pointer, is it the same as if I would index the array at index 2? And yes, this is the case. And I have an illustration for that. So we have our array variable, which we can think of as a pointer. And now in this pointer, we store array plus 2. And now here I just drew some illustrative addresses. They won't look like this, but just to understand this. So let's pretend that our array is at address 100, and then every byte starting from address 100 is one character in our string, basically. So what happens now if we add 2 to this array? Well, if we just think about it as adding this 2 to the address, then we add this 2 to the 100, which is the value of this array, if we think about it as a pointer, and we get 102. And if we draw this as an arrow now, so the address 102 is stored at this pointer, then this arrow points at the memory location 102, which is the character at the index 2. So the thing I just said before, here, dereferencing this pointer is the same as accessing the array at index 2. Because if we access the array at index 2, we get to this value. And if we dereference this pointer that we got by just manipulating the address, which is our array, we also got to the same memory location. And if we dereference that, we are getting the same value. So
one explanation to the title of the slide. We call this stack because, as I described before, we have the main function, then the reverse string function, the swap function. They are like a stack, also ein Stapel auf Deutsch. They stack over each other.
Let's pretend let's look at the memory of our program. Okay. Then now I have the second example, and maybe you don't see the difference right now, but I just changed the character array to an integer array. So I have here this integer, I stored integers in here, I again add 2 to the address of this integer pointer, and then check if it's the same. And okay, so let's look at the memory and see what happens. But as we know now, integers take up 4 bytes and not 1 as a character does. So for illustrative purposes, I drew it like this for the first or for the last element of the array at index 4. So you can actually see that it takes up 4 bytes of memory. And then for the next one, all of these, if you look at the address, also take up 4 bytes in memory. But I drew them a little bit smaller so that this illustration won't get too big. Now, okay, we have this array, which we think of as a pointer to the first element. This is at address 84, sorry, at address 84. And in our code, here, we add this 2 to it. So we add 2 to it, and now we would somehow get 86. But 86 wouldn't make much sense for an integer pointer, because this now points just in between of the first and second element. And if we would read this as an integer, this now would just be more or less garbage values, because we are mixing those two. So this somehow doesn't make much sense. But if we execute this, I don't know if it works.
No,
okay. If we execute this, oops. We execute this, we see that we have the output 1, which is true. So actually, if we add 2 to the array, we get the element at position 2, so we get this 3. So somehow what we did here is wrong. And yes, this is wrong. It does not work like this. It's more or less something like this. We again have this array, so this points to the first element. And now if we add 2 to this address 84 here, we are actually not adding 2, but 2 times the size of an integer. Because we have an integer pointer, the compiler automatically just adds 2 times the size of an integer to our pointer if we just write array plus 2. So this is what actually happens. And now we have 84 plus 8, so we have 92. And now this pointer actually points to the correct address of the third element. So at the address 92. And this is something that happens in the background. And you might not need to think about it in this course, but already having this understanding is can help you much later, because if you have pointers of different types, so if you have an integer pointer and add 1 to it, then the address gets incremented by 4. If you have a char pointer and add 1 to it, the address is just incremented by 1. And if you have a long pointer and add 1 to it, the address is incremented by 8. So depending on which pointer type you have, adding something to that pointer does different things. And it does this so that we don't need to think about how big our data types are, and we can just add things to our pointer to access the next element, which is like an offset of the size of the data type we're working with. Okay, so now that we know this, I want to try a quick example about how we could loop over a string using this pointer arithmetic.
So we actually code something today.
So, I'll call this my string, and I'll do it like this with the array. Let's write hello again. I can actually leave out how long the array should be if I directly initialize it, because the compiler now knows, okay, I want to store 6 characters. Okay, so let's loop over it like we're already used to. So a for loop, we have this I, set it to 0, and then I want to loop as long as I don't have this 0 byte in my string. I could use string length, but maybe let's just do it like this. As long as at the current position where I am, there is not the 0 byte. I'll increment the I. So yeah, I'll loop over the whole string. And now I'll just print the character which I'm at, so my string I. And then at the end, I'll also print a new line so we can read it. Oops. And if we execute this, we can see, okay, this just prints our string as we expected because we print one character at a time. But now we have seen that we don't need to index like this. So if we just write my string plus I, we also get a pointer to the ith element of this string, of this character array, and then we can dereference this pointer to actually get to the value of this element. And I'll try this out, and okay, we get the same output. So we really see that this indexing is the same as just adding a number to my pointer, which will increment it according to how big it is, and then dereferencing that pointer. But now we can do something, I think, which is even better.
Maybe you leave the previous loop here for comparison.
Yeah, okay, that's a good idea. I just write it like this. Now I'll create a pointer and just, I don't know, call it current character or something, and set it to my string. Current character will always point to the character that I want, which my loop is currently at. So I can just dereference this pointer and loop as long as this is not the null byte. And now at the end, I just want to increment this by 1, so I can write plus equal 1 to increment it by 1. So what am I doing here? Well, at the beginning, current char will just point at the first element because my string basically points to the first element. But after the first loop, I will increment current char by 1, and now it will point to the second element. And then in the next loop, I will increment current char again, and incrementing the pointer, I'll just increment the address and point to the third element. And now in the printf, I can just dereference this pointer to get to the character where I'm currently at. Yeah, I want this new line at the end. Let's look at it. And okay, we just get 2 times this string, which we have here. So yeah, using this pointer arithmetic, which we've just seen works with any data type, we can loop like this over arrays and strings. And because this incrementing a pointer is always takes into account how big our data type is, we could also have an integer array here and then increment our pointer into this integer array by 1, and it will automatically increment this pointer to the next integer in our array. Okay. Yeah, I have the code here too.
Any questions regarding this weird loop? Maybe I open it again for a few more seconds. 2 questions, so.
Yes.
By current char plus equals 1, plus current char.
Yes, of course. I just did it like this, so it's a bit more expressive in the beginning, but I can of course just write current char plus plus and increment the pointer by 1, like this. Okay.
More questions? Okay, you explained it very well.
One more.
Yeah, one more, yeah?
does it make any difference if you put plus plus before and or put plus after the current chart?
I think this was talked about in the lecture, and it's just the same difference as with any other variable. In this for loop, we are not using the value this expression returns, so it does not make a difference. The difference between the prefix operator, so when we have plus plus at the beginning versus the postfix operator, so when we have it at the end, is that if we look at the value this expression has with the postfix operator, it will be the value current char had before incrementing. And if we write this plus plus at the beginning and look at the value, then we'll get the value current char has after incrementing it. But in both cases, it will be incremented. Yeah.
Yeah, maybe really we make this as a. Like, I wanted to say this before actually, so make this a short example.
We could try this.
So we make the current char equals my string, and we take plus plus current char. And we dereference the result. Now, what is the output? So these are really exam questions. So, a small hint, these are exam questions.
I think E.
E.
Yeah.
Yeah?
We can try.
Try it. It's an E, correct? Yeah. Because you take current char, so this points to the H. You increment it by 1, so you get the E, so the pointer to the E, and then you dereference it. So it's really the E. Now change it. What is now the output? So now the output is H. Yeah, you want to say the same? You also wanted to say, you wanted to say E, yeah? Okay. Opinions. Who is for H? Who is for E? Again, equally.
I think more for H.
More for H, yeah? Try it. It's H. Why is that? You take the value of current char, and once you have taken the value of current char, you remember it. And then you increment it afterwards, after you remembered it. So it points to H, and then you increment it. So this plus plus at the end takes effect after this statement. So you take current char, it points to H, you dereference it, you get the H, and then it will be incremented at the very end.
Yeah, so if you write the plus plus after the variable, it will be incremented after you use this value, and if you put it before the variable, then it will first increment it and then give you the value. So we can see if I print current char at a second time, it will be the new value.
And yeah, these are exam questions as far as I am concerned with that. Yeah? You mean here? So you need to specify, also
Without this.
just like this, or with both?
I think like,
Yeah, so
like this.
In this case, both are E. Because we increment it, and then we dereference it, and then we dereference it again.
Yeah. So these prefix and postfix operator with this plus plus just makes a difference at the point you're writing them. So, and therefore, if you're writing them here in the for loop at the end, they don't make a difference because the for loop is not using this value we get back here.
So to make it a bit harder, this one more, yeah, one more. What's the result now? Yeah?
G. G.
G? Yeah? Other opinions? F? Yeah. So let's try it. So it's a small f. So we increment current char and take already the incremented value. So we point to the E. We do the dereferentiation. So here we really have the value E already. And then we add 1 to E. And what is the next letter in the alphabet after E? So this is F. So we really print F here.
And what happens now if we print the string again?
Yeah, so what happens if we print the string again? So I can write it. And my string. Like this.
Yeah.
Okay. Yeah?
Mm-hmm.
So this, he says it's the same. So who is for it's the same? Who says it's now with an F somewhere in the string? Ah, everyone got it right. Really?
No.
Why? No, now I'm also confused. Okay, now so this can happen, but you know the answer. Yeah?
I mean, we just have here the pointer to the E. We are dereferencing it and increasing the value there by 1. So we change this E to an F.
Yeah, so you hold the remaining part of the lecture.
Of course, if you do this plus, so the dereferencing this, we are not already at the value, we just look at this memory location. And then if we do plus, we are actually changing this memory location. This would then here the string would remain unchanged.
Yeah?
Yeah.
Yeah.
Because if this wouldn't work, then something like, because this works, we can dereference the first character and increment it by 1. And the thing we did before was basically the same, just with the pointer at the second character.
Yeah. So also we make mistakes, or at least I make mistakes. Yeah. It makes sense. We go to the memory address and we do not just take the value, but we really modify the value with the plus. Yeah.
Yeah, so these can get tricky with these pre and postfix operators.
That's why we can always try it. Yeah. So, yeah, 1 point for you. Okay. We have 10 more minutes. Now we should move on to the hints for assignment 2. And I will briefly talk about the two-dimensional arrays now and a bit more about input handling, because this is important for A2. I think you have seen two-dimensional arrays in the lecture, briefly at least. Just some motivation why you could use this. Yeah, for example, we measure temperature, and we measure the temperature in the morning, in the afternoon, and in the evening. So we have 3 values per day, and then we want to collect the data over a week, for example, over a month. So for each day we have 3 values, or we could even say for each day we measure the temperature every hour, so we have 24 values for each day. So it's kind of natural that you have like a two-dimensional structure where we have the daily values, and for each day you have these daily values, so something two-dimensional. I do it now only for 2 consecutive days that I can draw it, that I can draw the memory. Now, if you have the two-dimensional array with some temperature data in it, so we have 2 days, 3 temperatures per day, and then this is the value in the morning of the day 1, the temperature in the afternoon and in the evening, and then the same for the second day. Yeah, so you can again use these initializer lists of the two-dimensional array.
Yeah, and maybe if you think of this, I will come to this later. I won't spoil it.
Okay, yeah. So again, the look in the memory, yeah. So this is stored again consecutively in the memory. We start with the 0, 0, so the first day morning, first day afternoon, first day evening, and then the second day morning, afternoon, and evening. Yeah, so this is stored as a block, and for the first 3 elements in this array, we have the first dimension to be 0, and then the second dimension to be 1, and here it's counting upwards. Yeah, it makes a lot of sense to store it this way. Now, the problem is it doesn't work like this. So it works like this, but if we want to program with it, we need to think about it a bit more, and that all the pointer stuff works with it.
Yeah. So we said we can think of arrays as pointers, and now we have an array inside of an array. So what would this be in terms of pointers?
So we need to have a look on that. I have now several expressions here, my array. I wanted to print this, but I think I will not do this due to time issues. I just explain it. So forget about the size t here. We just look at my array and these values here. So my array is the address of the array. So if we go back to the previous drawing, my array is a pointer to the element with the value 4.2. Yeah, first element of the array. Okay, if we dereference my array now, I want to do this first maybe. I want to dereference my array. So we go along the pointer arrow, and now we should get the value. But actually this is not the case, because we have 2 dimensions. We still have an array now, because if we dereference 1 time, we get 1 step lower, and 1 step lower means we get this array here.
Yeah, so we get the address of the first element in this array.
Yeah, so my array and my array dereferenced both point to the same element, to the element with the value 4.2, but both is an address. We do not have the value 4.2. And if we would dereference a second time, then we would really get the value. So now I have a better drawing maybe. So think about this in steps, yeah? My array is the whole thing, the whole 2-dimensional array. Then you have this, and I draw this now again outside of the memory, because this is not a pointer which is stored in the memory. It's just a pointer that you can access in your code, which does not exist in real life, but you use it. And now if you do this dereferencation, then you go to my array at 0, and this is again an array, namely the array of the first 3 values. And if you dereference this again or index it again, then you go 1 pointer arrow along and you get to the first element. Yeah. So if my array at 0, this is the pointer to the element, and if you dereference it or index it, then you get the 4.2. If you just do my array at an index or a dereferencation, you are only at this level here before, and you are not at the actual array already.
So it's like a pointer to a pointer. You need to dereference it once, and then you still have a pointer, and you dereference it another time, and then you have the value.
It seems really awkward, I must admit. And I think last year when we talked about this, also we were a bit confused. And yeah, it seems really awkward, but yeah, it is necessary, and we will see this. So we have a bit more on the slide now. Assume we have my array plus 1. So this would mean we take my array. This is this two-dimensional thing, and want to get the element with index 1 of it. And this two-dimensional thing, getting the element with index 1, is not the first subarray, but the second subarray. So we need to be here at the very top, these three values. And this must meet the requirements of pointer arithmetic again. So we take my array plus 1 is actually my array plus 1 time the size of my array dereferenced. And my array dereferenced is the size of such a block of the array, of one of these subarrays. So this is size of my array dereference is 3 times the size of a double, because these are all like floating point values and are stored as a double. So we really go, if we add 1 in pointer arithmetics to my array, we go upwards 3 doubles, and this makes sense because we want to skip the whole first part of the array and go to the second part of the array. And I also have a different operation here. If we dereference my array and add plus 1 afterwards, then this is the same as dereferencing my array. So we just think about the lower subarray. And if we add plus 1 in the subarray, then this is equivalent to going up 1 double in the memory. So this is my array at 0, yeah, plus 1 times the size of the double. So we go upwards 1 step here.
So basically at the first level, if you just think of my array, then my array is the pointer to the first array. And if you increment it by 1, then my array is the pointer to the second array. And yeah, and if we dereference that, then we have the pointer to the first element that of this array, basically.
Yeah. So you can also think about it in the outer dimension as these 3 values are just 1 value. These 3 values are just 1 value. And if you go to 0 or 1, you go to this block. And then when you are at the block, you can do this finer separation and go just by 1 double. And before you have a block of 3 doubles in this case. Two-dimensional arrays, yeah,
Yeah.
they're a bit difficult.
Yeah.
Yeah. Yeah, so to the 12, the question was how to get to the 12.7. So this my array dereference plus 1 just points there, and then you need another dereferentiation to get the value of it. This is just the pointer which points there. Yeah, absolutely correct. Yeah. I didn't get it.
So both, it points to the, it can't point to the whole array. So it will point, so if you think of as the whole array of both of those arrays, then it points to the first element, which is this array, but it can't point to this whole subarray, so it will point here. So actually, you can just dereference my array 2 times and get to this 4.2. Yeah, so because my array has 2 elements which are both arrays, and it points to and my array is a pointer, or you can think of as my array as a pointer to the first element, so it points to the first array, yeah, which is again, you can think of as a pointer to the first element.
Yeah, so it points to the first block of 3 elements, and the block of these 3 elements is the same address as the first element, because yeah, the first element of the block is also the address of the whole block.
And now this can get really confusing when casting those to actual pointers, and yeah, but we won't look at this now.
Yeah, one more question.
Yes?
Can multidimensional arrays contain different data types?
No.
So it's always an array in C is always the same data type for every value.
So even all subarrays must be the same type, which means all subarrays must be an array of the same type. Because if we have one char array and one integer array, this wouldn't be the same type.
Okay, so accessing elements, we have seen this also before. So this, my array at 1 and 2, can be again rewritten as we take my array plus 1. So we go to the second block, dereference it. So we are then on the on the element level, not on the block level, but on the element level. Then we go again 2 addresses upwards and dereference this. And then this is the same as we would say this, the indexing at 1 and then at 2. Also have the picture here. So if we take my array at 1, 2, then this is clearly the element 6.7. And if we take my array plus 1, then we need to go upwards 1 block. And then we dereference it. So we think then about the single doubles, about the double elements. And then on this double level, we just go upwards 2 elements and we get the pointer to the same element as before.
Yeah.
And if we dereference this, then we get the 6.7. Yeah. Looping through a 2D array, okay, this is easy now. You have an array. In the case of a 2-dimensional array, we really ask you to give the looping variables meaningful names. If it's just I and j and it's a bit more complex than this, it's not readable anymore. What is the outer loop? What is the inner loop? So in this case, we could say, okay, the outer loop indicates the day. The inner loop indicates a timestamp or a time or whatever. And then we could just print the array at a specific day at a specific timestamp or time or whatever. Yeah. But this is then meaningful. Yeah. And of course, if you use 2-dimensional arrays, you use the indexing here and not the pointer arithmetic from before, because this is awkward looking at it.
Yeah, because here it's clear, okay, my array is a 2D array, so an array of arrays. And with this day, we basically access the first or the second array, and then with the timestamp, we access a timestamp in that day.
Okay, I think this is clear. You can also do this with strings. Yeah, you can also store strings in a 2-dimensional array. Then these are, again, we know this, these are character arrays. So if we look at the memory visualization, we have at index 0, 0, the string hello. Yeah, so this would always be 0, 0, 0, 0, 0, and then position 0 to 5. This would be a string. Then, and directly after this 0, there is the W, but I can't draw it because it's then too large. But directly after the 0, there's the W in the memory, and this next string is stored. So you can also store strings in a 2-dimensional array because the strings are just characters, character arrays. Yeah. Last question, and then we come to 2 slides about input, and I must apologize in the lecture, but this is necessary for A2. Okay, so we have this character array with hello and world. And now I write my array 0, position 5, I write a space. What happens? Probably this print is the more important one. So this is just a 2-dimensional array. There are 2 strings stored, and now in the first string at position 5 a right space character. Yeah. It would print hell. Okay. Other guesses? Yeah. Yeah.
Yes, so this is the position of the null byte in the string.
So this would happen. We would have here the HELLO, and then the index 5 was the null character before, and now we write a space here. And after the space, there is immediately, so ignore again this, the dots here, the W and ORLD, and then the null byte.
And only then we find the null byte. So printf will now print hello world, because it thinks that this is just one string, which ends at the first null byte it finds, which is this one at the very end.
So it's crucial that you don't mess up with your indexing and you don't don't miss your null bytes here, because then the strings are merged together. Okay, 5 more minutes or 3 more minutes, and then we are done. You need this for assignment 2, user input. This EOF means end of file. This seems a bit awkward at the moment, because what is end of file in a user input? You trigger this if you press Control D in a program on Linux. I can do this now. I open a shell here, and I press Control D, and the shell closes again. So I open it, shell is opened, press Control D, it closes. So this Control D is often used to terminate a program. And you will need to do this also in assignment 2, and that's why we talk about it. And the important thing is just how do you get this information, and the variants that you use for reading in an input will be fgetS or getchar. So we talk about these. If you use getchar for a user input and you press this Control D, then the getchar will return EOF. You can check this here. This is a constant, and this is already defined, and it has the value -1. So you need to check if the C, the character that you read, is EOF. It has the value -1, and in this case, you can then terminate your program. I can copy it.
Does it work here?
No, it doesn't work here. I need to copy it. Do you mean that this does not work?
Yes.
Okay. stdio.h. We compile it. We run it. I press Control D. Why does it not work?
Character. So getchar returns an integer, and this is because getchar needs to return end of file, and the character can only represent 2 to 255, but end of file is -1. So we also need to store our character now as an integer to check if it is end of file.
Yeah, that's very nice to have something so smart next to me. Okay, we store it in an integer, then we can really store the value -1. And if I now press Control D, it works. Okay, that's good that we talked about it, because you could have made this mistake in your code, and now we did this already here, so you can't make this mistake. Yeah. And there is also an option for fgetS, and now I don't have the same mistake as before. fgetS also has a return value, and it returns null if no character is read. So you need to check if the return value of fgetS equals null, and if this is the case, then you again know that the user entered Control plus D. So check it again. If I press Control D,
Yeah.
this now worked without mistake. Okay. You will need this in assignment 2, and that's why we put this at the very end of the practicals. And now David is already looking a bit mad at us, so we should conclude for today. We did a lot of drawings.
Yes.
And
So I hope that now pointers made maybe a bit more clear, and also how arrays interact with pointers and all of this.
yeah, and we've seen arrays, pointer strings. We see the reverse string. We see a lot of pointer arithmetics. And this 2D array and the user input is a good hint for assignment 2. Yeah. Thank you. 8 minutes break, I think. And then the lecture starts with more interesting topics.